Hello Internet! Today I figured we'd look at some more shader stuff, and specifically I kind of want to play around with snow on top of our rocks here. So these are just some sample rocks that I've pulled from an asset pack, and we don't have any snow on them right now, and we could add some. This pack actually does come with snow-covered rocks. The thing is that snow is not dynamic, it just covers the top of the rock, which is great, but we can actually use a shader to do much more with this. So what I'm thinking is, instead of having a predefined, pre-textured rock, we can actually use a normal to define where the snow should be. And so every face on a model is going to have some sort of direction that it faces. And so the top of the rock is going to face up and so on. What we can do is actually define some other normal where the snow should be, and compare those. And so if we want the snow to fall directly down, we can actually compare the vector of the mesh to that vector. And then based on the difference in the angle, we can actually either draw the snow covered texture or the normal texture. And so that's sort of what I want to do here. So we need to do something. What did we call this? The snow topped. So we're going to create a snow topped shader that is going to do hopefully what this is doing. I'm going to skip some of the more complicated bits of this. This shader also is the standard shader, but it has things like ambient occlusion, metallic maps, things like that. I'm not going to use those because what I want to focus on is mostly on the snow bits, and how to do that texture transition. But if you want to do that, you can just add those in later. It shouldn't be too much extra work. And so we're going to do a snow topped or snow covered shader. And so this is just going to create our basic shader. It's going to do something, I'm not entirely sure what yet. And this is standard shader stuff. So we have a color, a main texture, a glossiness, and a metallic. We aren't going to use much of this. The main texture is actually going to be the same. So if we apply this snow covered texture to our previous rocks, we should hopefully end up with snow-covered rocks. So let's take this rock 5 material and apply our new texture. So it should be under custom somewhere. There we go. And should be called the snow-covered shader. And so we lose a little bit of the texture. You can see it's a little bit smoother. It doesn't have a lot of the cool extra details of it, but you get the general idea. And so we've gotten this nice smooth rock. And so every part of this is going to have some sort of normal. We can actually just close that other thing. So I believe this is going to be a guess here, but I believe there is a world normal that we can plug in as the input. And this is going to actually be the world space normal of the point of the fragment of our mesh. And so when we talk about vertices and fragments in a shader, we're talking about two different parts. So if we go back to this and turn on our shaded wireframe, you can see there's a bunch of black lines. That's going to be hard to see because this is 4K. If we go to wireframe, you're going to see the triangles that compose our mesh. Each one of those points in our triangle, each one of the vertices that actually makes up a mesh, has extra metadata about it. And that's going to include things like the UV coordinates so that we can look up textures. And it's also going to include the normal, which is the direction that specific point is facing in the object space. And so when we talk about a fragment is everything in between that. It's what you're actually kind of seeing. And so in between those, your graphics program is actually going to interpolate between those and get you an actual value out. And so if we have a triangle, we can have 3 different values on every point of that triangle. And if we look at a point in the middle, it's actually going to figure out what the value should be at that specific point and return that. So you actually get the correct value. Now, we're using world space normals, which our object doesn't have, but we do have a world space transformation. So the way meshes are drawn is they need to know where they are in the world, where the camera is located, and things like that, so that they can actually move a mesh into the relative space to draw on. And so we're actually going to be using some of those matrices, or Unity is going to be using some of those matrices in order to transform this object space based normal into something that we can use here. And just by using a world normal, it should save us some extra work. So we don't have to do that transformation ourselves. And so if we actually take that in, I believe, if I've done this right, we should be able to do something as simple as draw it out. So we have it as a float 3, so we can plug that into the RLBeto, which is also a float 3. And so we should see this be replaced with colors. And so you can actually see there's a bunch of different things. The black is negatives because this is going to go negative. But we have green, which is our Y value, red, green, blue. And so blue is going to be on our Z axis in world space. And then the red is on our X axis. And as we rotate this, you can see the vertices, the vertex colors change. The colors of our mesh change. And that's because the world space is actually changing with that. If we were just using normals, like the normals attached to our mesh, we wouldn't expect those to change. But because we're actually using the world space, they should change. Which means we can actually use a single mesh with a single shader and a single texture and rotate it like on its side like this and still get snow where we expect it to instead of on the top or something like that. So that's one of the advantages hopefully we'll get from this. So now that we have that, we know that that's working. And so the other parts that we need are going to be some sort of reference. We need some place that our vertex is going to point. And so we are going to have a snow origin. This is not a good name. So snow direction maybe is a better name. And so we'll call this the snow direction point or something like that. And we'll make this a vector. And so that's going to be a four-dimensional vector. We're going to ignore the fourth component of that. We just need a 3D vector so we can compare it to our normals. And so this is going to come out as just that 0, 0, 0, 0. And we should actually probably initialize this. So let's have it default to coming from the ceiling, from up top. And so that's that. The next thing we need is some sort of snow amount. This might not be the best name, but we're going to do a snow amount. Names are always hard. And we're going to just set that to like 0.1, I think. And so this is going to be a range effectively from, well, we're calling it a range, so let's use a range. It's going to be a range from 0 to 1. And the idea is if it's at 1, the entire thing is going to be covered in snow. If it's at 0, none of it should be. And then as you increase from 0 to 1, more and more of it should become covered by snow. So that's sort of what we want to accomplish here. This gives us a way to kind of like, if we have like procedural amounts of snow, we can just increase that amount and slowly our terrain should cover in snow. So let's pull those both in. So we have our snow direction and our snow amount. So I'm doing this here because we've defined up here two properties that Unity sees. These are sort of like metadata for Unity, but our shader actually needs to store that data somehow. So we're going to do that down here. So we need a vector, or let's do a float 4 to store that, and then a float to store our snow amount. And so now that we have all of that, we need to figure out what is the current snow direction for our fragment. And so what we're going to do is output some float, which is going to be our snow coverage. This is a less good name. I'm doing that a lot. So snow coverage, and we're just going to take the dot product between the snow direction and our world normal. So we're just going to do dot of the world normal and our, snow direction. I am not going to normalize the snow direction in here because if we did that, we would actually end up doing it for every single fragment in our, so effectively for every pixel that we drew every frame. And that's just a lot of extra computation. Instead, it's if you're manually adjusting the snow direction, this calculation expects snow direction to be normalized, which means it has a length of 1. And so the reason we want that is because a dot product is going to return, when given two normalized vectors, it's going to actually return the cosine of the difference between the two vectors in whatever amount of dimensions you want. And so we're doing a 3-dimensional comparison here. And so we're going to get some sort of cosine between 1 if they're perfectly in line with one another, to 0 if they're perpendicular like this. And then if they're going the opposite direction, we're going to get -1. And so we are going to get that. But that has a range of 2, between -1 and 1. So we're going to add 1. So now it's between 0 and 1, or 2, sorry. And then we're going to divide by 2. And so this is going to get us some range between 0 to 1 snow coverage, where 1 is perfectly in line and 0 is not. Just as like a really basic example. And so with that, we should be able to do some extra stuff. But we don't actually need to do too much more. What we can do, just to kind of prove out that our thing is working, we can write the snow coverage out to the red color channel of our shader. And so this should draw red where we would effectively want snow. Or it will fail to compile undeclared identifier world normal. In.world normal, there we go. That'll fix that. And so now we get this nice red thing, and we should hopefully see darker bits on the bottom. This is going to be hard because we have a lit texture. I didn't think this through at all, did I? Snow amount is not used right now. This is 0 to 1. Okay. Do 0, 1. All right. And so that gives us a bit of a better example. We have a hard red on the right side, and then we have a dark or black on the back side. And so what we want is to have snow on that red side, and then as we move across, we're going to not have snow. So there's going to be some sort of cutoff here. And we are doing snow amount from 0 to 1, which means this is actually the wrong way. Because that red part was the part that was facing the vector that we wanted our snow to have. And so that's going to be 1, and we actually want it to be 0. So we're going to invert this. So we're going to do snow coverage equals 1 minus the snow coverage. And then we're done. And so that now we have 0 up to our snow amount is going to be snow. And everything else is not. And so we need some way to actually do that. And I am blanking, but what we could do is use if statements. If statements do work in shaders, but you shouldn't use them. Branching on a GPU is one of the slower things you can do. And so if we start sticking conditional things in here, it gets much slower. So we actually want to avoid that where we can. But we could do something like if snow coverage is greater than our snow amount, do something, otherwise do this other thing. But what we actually want is to come up with some sort of equation to do this. This should compile, unless I've completely lost it. Yeah, it's fine. So that will work. And you can do this as sort of like a templating thing. Maybe we can even go forward with this and write this. But as you actually try to use this, probably not the best solution because it's going to be slower. So if the snow coverage is greater than the snow amount, then we're going to want some, let's see here. We're going to want a snow strength. And we'll do that equals 0 if that's less than our snow amount. Then we want snow strength equal to 1, which means we're either going to have like a hard edge on our snow. So it's either going to be 1 or it's going to be 0. And so if it's 0, then we don't do anything. And if it's 1, then we do this thing. So this will be our snow. Snow color. And we need to read in our snow texture. So we haven't done that yet, so let's add that in. So snow texture, or text, that's probably better. Snow albedo, white, sure. So this needs to be a sampler 2D, like so. I'm just going to put it with the other one. And now we need to sample that. So when we pull out our snow color, we want to pull it from the snow texture. We can use the same UV coordinates as our main texture. We don't need a separate UV for this. That doesn't make a lot of sense. It's going to be using the same coordinate system and everything, so that should be fine. The downside of doing this is if we go back to Unity, we'll see there's this tiling and offset thing. And so the albedo and the snow albedo have this. If we use the same UV, that won't work. So we can't actually change the tiling of our snow because, well, we aren't using its UV, so it's not going to work. So I have a snow texture here. I'm just going to apply that just so it will work eventually, and we should be good. But now we're pulling out the snow texture. We have our C, and so all we need to do is do C times 1 minus our snow strength. So if there is any snow, then it will get subtracted. Otherwise, we're just going to add on our snow color, which is just going to be times our snow strength. And so this is just a smoothing function. It should keep them one side versus and interpolate into the other. And so as we do this, we should now see snow pop up over here. And that looks awful, but that's all right. We can change this and make this a little bit nicer. There are some techniques that I've personally liked to use to kind of smooth this out and make it a little bit nicer. We can actually look up things like the depth map of our rock, for example, and use that to kind of help smooth this out. I'm not going to cover that here, but you can effectively change this function so that different values get returned here. It gets a lot easier if you have a normal map for your rock, because then you can just use that and place that in here. And then those modifications of your normal map can be used to actually modify the normal that you could plug into the initial function. So what I'm talking about there is, instead of plugging in this, well, actually, I think it will still work if you just plug in a normal, but you can actually use the normal map as a function of this. And so you get a little bit more complicated appearance, and it looks less smooth. Because of what we're doing here, we're going to get something that looks very smooth around the corners. And it does work. You get sort of a nice coverage, but again, it's very smooth, and it doesn't like fill in the cracks, for example. So maybe we'll look at a second video where we actually take a look at that. But that is a little bit outside of what I want to get done in this video, so we're not going to cover that here. So if you want to see that, maybe consider subscribing. Haha, plugs. So now we need to pull out this if statement because I don't like it. And so what we can do is make something up. I'm going to think on this because I haven't thought on this. We could maybe do something like this. So snow coverage equals snow coverage less than snow amount. This should actually work if I'm thinking about this correctly, and actually get rid of everything. And all I did is actually pull out the if and replace it with this Boolean logic. And so this is going to return 1 if it's true, and 0 if it's false, which is exactly what we were doing previously. We're just not branching. We don't have an if statement to actually do that. We're just doing a comparison here. And so hopefully that kind of covers a lot of what we needed to do here. We have the snow drawing. We have everything else working. Like I said, some of the other textures are missing on this specific thing because that didn't make sense. I think it makes sense to actually expand on this and do a second video. And so I'll add in all those extra textures in the next video. So we actually have that really nice looking mesh again. So we actually have all those depth maps and normal maps and things like that. And it should improve the quality of this quite a bit. So that should be coming shortly. But hopefully this is enough to kind of get you thinking about that. And just to kind of show what this can be used for, we can do like 1, 1. That actually won't work because that's not normalized. But like if we do 1, now we have snow on the top of our rock. But if we want to rotate our rock, we can actually do that. And the snow will move with it. And so we can actually use this mesh to create more complicated scenes than we might otherwise be able to. So we can like move this around and stand this one up, and we still get relatively good looking snow on top without having to do anything extra. And so that's sort of one of the advantages of doing something like this. The downside is you have to figure out the shader for it. And that can or cannot be very complicated. But I think this is a relatively easier way to kind of get this effect and get it to look nice. And then you can kind of take anything that looks something like this and start adding to it. And then if we wanted to, say, increase the snow amount, we can just adjust the snow amount. And say it's snowing or something, you can just slowly have it cover the tops of it, or maybe melt over time or something like that. So you can kind of play with this to do whatever you want it to do. But yeah, that's it for this video, I think. If you want, consider joining our Discord. We have a World of Zero Discord. There's a link in the description, and there's a bunch of people there that share their projects, talk about different programming things, and just sort of discuss gaming and programming and software in general. So if that's something you're interested in, we just had a really interesting conversation about like software architecture that I'm personally really excited about. So yeah, there's some fun things that happen there. Otherwise, maybe consider subscribing if you want to see more content like this. And if it was something you really liked, maybe consider leaving a like and maybe a comment to kind of say this is cool, or if you use it in a project, I would love to see what you do. Either shout me out on Twitter or here, drop a comment, something like that. It's really cool to see what people turn these kind of things into. And finally, this project will probably be ending up on GitHub shortly. So if you want to check it out and use it in your own projects, you should be able to grab the code after I touch it up a little bit and get that second video recorded. So yeah, there's that. But until next time, see you, internet. So I lied. We're not going to do a separate video for this because I was adding all of this extra data and it just sort of worked. So we're just gonna go with this and add this on to the end because I think that makes sense. So this is what it looks like currently. And so I've added a normal map, a metallic map, a occlusion map, and I think that's it. Yeah, that's it. The height map I added, but I ignored that because there isn't an option to output a height map, and I'm not going to implement it myself because that just is a lot of extra work. But this is what it looks like, and I think this is pretty good. And it's actually not too difficult. I say after looking up a few different things. Turns out Unity does magic, and that causes a few problems. So I'm going to try to walk through the magic, and then we're going to see what happens. And so the world normal is still there, but now there's this fun thing called internal data added to our input, and it doesn't have a semicolon. If you add a semicolon, it breaks. Fun fact. So don't add a semicolon after the internal data, but if you just put internal data at the end of this input struct, Unity is going to inject a bunch of internal things that it uses to do a bunch of other stuff for you. And some of that stuff does this. So what ends up happening is we end up outputting the normal from our normal map lookup, which is right here. we output that to our normal. The problem with that is that overrides the world normal. And so if we start doing that, we end up not getting a value for our world normal unless we include this internal data. And even then, it isn't necessarily correct. And so in order to actually do the correct lookup, we need another world data, or world normal, which is going to be a world normal vector. And so we're going to plug that in and give it our input struct, this thing up here with all of the internal data so that Unity can access whatever is in here. It doesn't say what it's going to access in there. And then we just need to give it the output normal, which is actually the normal that we're giving to our mesh. And so by giving it that, we're giving it the internal data about what normals it has in world space, and then also the normal that we're outputting so that it can use that. And then by using that in our calculation, instead of using everything else, it works. And so it ends up using the actual normal. And so then we get this fun shader, which looks much better. And so this is sort of the look that I kind of envision when I think of this. Here's like a little slight sprinkling of snow on top, and then we can get the tops covered. This still isn't perfect. There's some other things we could fix with this. For example, like the cracks in these flagstones or rocks or whatever. They don't have anything in them. The cool thing is like the ledges do. So you can see like these ledges have clear like parts of them that are facing up. And so you can actually see snow got caught in them. But on top, you would kind of expect snow to like either be in those cracks or something to kind of fill that up. That doesn't happen because they're a slope, because of that's what the normal says. And so they're going to appear not covered. So that may or may not be what you want. You could fix that if you want by factoring in like this height map, for example, or even using like an occlusion map to kind of help with that, and having like highly occluded areas be more likely to have snow because they have less things affecting them, or maybe have less snow because they have less things affecting them. It depends on what you want. But this gets us where we need to go. So you'll find this code out on GitHub. I already covered that in this video, so I'm not going to go too much into that. But this will be out on GitHub, so you can go look at it. The big changes in order to get all of this working, we're moving the normal above everything else. That's important because if we try to do this world normal first, before we set the normal value, it doesn't work. So we'll just get what we had before. And so that isn't any good for anything because we haven't obviously set the output normal. So it doesn't know what to look at. So we need that down there after we've looked up our normal and set that output. Once we've done that, we can then actually use that in our calculation, and everything else is the same. We don't need to do anything other than change the normal value we're plugging in. This world normal is the only thing that's really changed. And so if you actually modified like this function, you can get a whole bunch of different results that look like what you want. So that's that. So yeah, I'll leave it here and see you for real this time. So see ya.